Great. I think that should make the stream go live. Let's close this. We're learning how to use this. Oh, no. Let's do that. This. Okay. Let's make sure that this is in fact working how we think it's working. Trying something new this semester for how I'm streaming. If it fails miserably, we'll switch back the other way. But college, this. Okay, so that works. That, can we see the typing? Hold on, wait, is there volume? Okay, so that, nope, there definitely is. Volume. Okay, cool. And then one more thing we're testing. So if I switch my window, what happens? Oh, I see hello chat, nice. It's a good sign. So I did a switch. Okay, it's still just recording that. All right, it doesn't really matter. So basically for those, as we're starting out here, previously I would just like stream the entire display, but now I'm trying to just stream one window. Hopefully that makes things slightly better from a viewing perspective. But if it falls apart, we will switch to streaming the entire desktop again. Okay, nice. All right, I see there's people here. I see someone is chatting. All right, before we start, let's see, does anyone have any questions about the logistics of this class in terms of how the heck is this all running, or anything related to the class at a high level that's still confusing? We'll give people a few moments. I have a question. I could not find the tmux conf in opt. All right, we'll quickly address that, even though that's not really a question about the class as a whole. But the answer to that real quickly is in opt.college. There is tmux.conf. This thing. All it does is that. But you can copy this into your home directory, and that will address that. I wonder if I do this, what happens? Do that. Do that. Seems like it's working. Cool. All right, I guess you can like see my mouse moving when I switch windows. Good enough. All right, this means that I can actually like, all right, this works. All right, is there any other questions that people have before we jump into talking web? No, not seeing any. All right, let's jump into it then. If you ever have questions, maybe we can side tangent throughout this to address them. But I am going to be talking about talking web here. So we are going to look at this from a practical perspective. So the current lecture videos up there approach this from a very conceptual perspective. Now we're going to approach this from a very practical perspective of what the heck does this HTTP stuff actually look like? And how do we use Python, netcat, curl, etc. to do it? Okay. So the very first thing we want to do to understand this is, I think the simplest thing in some ways, also the least simple in other ways, is the netcat tool. So if I, oops, that's not what I want. I want new, how do I do this? Split editor down, is that this? Yes, this terminal in editor area. Okay, now we got two terminals, sweet. Let's make sure we got two terminals are showing up. No questions about that, right? We got two terminals, very visible. Just got to mind the top right corner. All right, so if we want to start communicating with some other host, some other program, some sort of other thing out there on the web, this is the topic of networking. So networking deals with how do we connect two different entities together and get them talking. Now, normally this kind of specifically implies stuff like TCP, IP, we got Ethernet frames going around, all that sort of thing. But just at a very high level, we want person A and person B to be able to talk in this digital domain. So for illustrating this, we've got terminal top and terminal bottom that want to be able to talk to each other, right? How do I transmit, like, for example, if I say echo hello, how do I get this hello to maybe appear over here to network that communication across? The answer is that we use a tool called netcat. So netcat is a very simple, I guess dash help's not an option. It's a very simple tool that is just going to do networking. So if we look at this, arbitrary TCP and UDP connections and listens. So the TCP, UDP, these words, they don't really matter right now. We'll get to that later in the course in a different module. All that matters is that this tool allows us to do networking. And there's concepts specifically of we have someone connecting up to someone else, and then once they're connected up, they can talk back and forth. So we are going to be using IP for this to occur. TCP IP. Again, the details of that do not matter, but hopefully you've maybe heard of something like an IP address. So if I type IP space A, we're going to see, again, the specifics of this don't really matter. We have this loopback interface thing that has the IP address of 127.0.0.1. So maybe you've heard of 127.0.0.1. It's localhost. And this just means, in a broad sense, we're kind of talking to ourselves. We're still using the same technology of if we wanted to talk to someone on the other side of the world. But ultimately, this localhost loopback IP address, this 127.0.0.1, it's just talk to ourselves. So that's what we're going to do here. And the way that we're going to do that, for the purposes of demonstrating that, is that we're going to start listening with netcat, netcat-l. -l means listen. And if we wanted to know that, we could look at the man page, look at -l, right? -l, listen for an incoming connection. So we're going to do netcat -l 127.0.0.1, and then we have to specify this port thing. So this port thing is just, imagine you're going to an apartment complex, you're delivering mail there, and there's a whole bunch of apartments. Well, each one's kind of like a sub thing under this IP address. So we're just going to literally use 1234 as our port number. It doesn't really matter. All that matters is that the person that's going to start sending to them uses that same port number. So netcat-listen, VS Code notices that. We can ignore that. And then on this side, what we're going to do is we're going to talk to it. So we're just going to omit this -l. We're not listening. And we're going to type in 1234. And now, if I say hello and press enter, that appears over here. Likewise, I can type world, hit enter on this side, and it appears over here. These two people, I am talking to you. I am talking back to you, right? These two things are now networked together and are able to communicate over localhost 127.0.0.1, over port 1234 specifically, and they're communicating. Yeah, I mean, that's really just it. And specifically, every time I press enter within this netcat program, that is when the data gets transmitted. So netcat specifically does that networked sending of data on enter. Hopefully that makes sense. So this is very powerful. So for example, I could write a very simple bash program. Maybe you're familiar with bash, maybe you're not. But hopefully you kind of get the idea here. If I do this simple little program, this is just a for loop counting to 10. So, not counting to 10, not true. We need a do in there. We are failing miserably for I, and we need an in. Okay, so this counts to 10. We could add a little sleep 1 here, and we are going to, every second, add more data. So, as you could expect, right, we could then send this over the wire, send this to this other person. and they could start communicating, right? This fancy little program of counting to 10 could now talk to this person. So 127,001, 1234, this little pipe thing, for those unfamiliar, means take the output of all of this and push it into this program. So rather than manually typing as we were doing before, it's going to just send this through to this. So let's look at that. So we can see 1, 2, 3, 4, 5, 6, right? It's counting up every second over the wire. So this is a basic primer on netcat in terms of networking. So what the heck is HTTP? HTTP is a specific format of message for communicating. It specifically has some structure to it. And let's go ahead and take a look at that structure. So rather than just sending arbitrary messages, it's going to have some format to it. So if I netcat listen here, and then I run the following command, or actually before we even run the following command, let's imagine adding some structure to this. Let's imagine some sort of program that says, what does it say? It says, I would like for you to give me the message.txt files content, right? Some sort of English request. So this gets sent along, and now we don't really have a message.txt, but we could imagine creating one. So let's actually, oops, that's not the right thing. New file, text file. We are going to create a file, and we're going to say, this is a very interesting message. And we're going to save this, and we're going to save it as message.txt. So we can imagine that this person just received this request and is asking for the contents of message.txt. So what should this program do? And I'm going to do it by hand, is that this person should come over here and send this. And now they've got the result of this. So this is a protocol, and maybe you say this is an English protocol, right? We're just making a request for something, and that request is being carried out. HTTP is the exact same idea. The format, though, looks a little bit different. So hopefully you've watched the lecture videos showing off this format. But if we set up this server, or not even server, we're going to carry this out by hand. And hopefully I don't make any mistakes. If I do, we'll fix it. And we're going to switch over to curl pretty soon so that we're making valid requests. And pretty soon we'll also switch over to a real server. What we're doing instead is we're typing out, instead of English, we're typing HTTP. We're sending HTTP. So we're sending get message.txt HTTP 1.1. So why this? Why all caps get? Why HTTP 1.1? Well, that's just what the protocol says. The protocol says this is what it's going to look like. And it's specifically going to have the thing that you're looking for out of some root directory. There's a concept of the root file directory. We are requesting message.txt. We do this, and now similarly, what this server should do is it should say HTTP 1.1 200 OK. And what this means is, okay, yeah, I'm also speaking HTTP. I send some status code 200, and I say, okay, this has been found. And then we do content length. And the content length is going to be however long this message is. So I am going to, let's see here. How do I do this? Terminal, create new terminal in editor area. Let's quickly run Python. And we'll say 35. We're not being very, maybe it's 36 because there's a new line character here, but we'll say there's no new line character. And then we say enter, and we say this and we just sent an HTTP response. So the request of looking for this message looked something like this, and then the response looked something like this. So let's actually show that this is what it's looking like by spinning up an HTTP server and then using a real client for communicating. So, because we're also leaving out some more details of what other things are going to be added, but this is more or less correct. So Python actually allows me to spin up an HTTP server. And when I do this, by default, it's serving on any IP address I can connect to over port 8000. So rather than port 80, or rather than port 1234, it's serving it over port 8000. And so if I use a different method, actually, before we even use a different method, let's stick to netcat. Let's type this request and show that, hey, we can do this with netcat, because guess what? In this assignment, you will be using netcat. If I type netcat 127.0.0.1, 1.2.3.4, not 1.2.3.4, this immediately exited, and you can see a little red thing over here. It didn't connect. No one was listening there. We're listening on 8000 now. And I type get/message.txt http/1.1 and hit enter, and then hit enter again. We will see what comes back. Well, I guess the server is not speaking HTTP 1.1, it's speaking 1.0, but same idea. HTTP 1.0, 200 OK. Now there's some more data than what I showed before, but none of this is strictly required. This server thing, this date thing, this content type, none of these are required. But you'll see that we also have content length 35. I believe that's what we sent before. Yeah, 35. And then also a last modified. These are all optional things. Some clients might appreciate receiving this information. But really all that matters here is this HTTP 1.0200 OK, this content length 35, and then the contents of the message. And look at this, right? It's just like when we spoke English over the wire to someone. We just spoke HTTP over the wire to someone, and suddenly we got our message back. We got our reply. Now we need to know how to parse this. We need to be speaking the same language. We need to all be agreeing we're speaking HTTP. We can see we got our message back. And that's exactly what HTTP does. It's a very simple protocol that looks roughly like this on the first line. Get something, say we're speaking HTTP. It says, hey, okay, and then gives a bunch of metadata, including the length, and then it sends the data of that. So this is the Python HTTP server for doing that, and it's able to send message.txt. You could see a different example, actually, before I exit out of this. Let's instead go ahead and say get/not-here.txt HTTP 1.1. And we're going to see something else comes back. Instead of 200 OK, we got 404 file not found. So maybe you've heard of a 404. Well, guess what? This is a 404 file not found. With some more metadata, we got, instead of sending plain text, we're sending HTML. This server has decided to specifically be sending HTML back, and it's specifically trying to say, hey, I didn't find it. And the reason for this is more common than not, the place where you're using HTTP is in your web browser. You're using HTTP in your web browser, and your web browser is running HTML, rendering HTML. And so when you go to this URL, this is not a URL, but this is a path part of a URL. In your browser, it will complain and say not here, and that will be that. Okay, seeing the chat, if there's any questions, not seeing any questions, we will keep on rolling then. Okay, so this has been using netcat. Now, manually typing out HTTP requests by hand is a very abnormal task. You will be doing it in this assignment because we want to make sure you understand what the HTTP structure looks like, so that's why that exists here. But it's much more common to, I've already said, use something like a web browser as your client. However, since we're currently operating on a terminal, also a very common way of interacting with these web servers is using curl. So curl knows how to parse an HTTP response and give you really just what you're looking for. So if I curl, and I curl specifically to 127.0.0.1, and just to be precise, I don't remember if this is going to be required or not, but we'll put HTTP in front just to say, hey, we're speaking HTTP, and we're looking for message.txt. So you've probably entered something like this into your web browser before. Now, probably you haven't entered, or maybe you have entered a direct IP address, but you've certainly entered something like https pwn.college, and we're going to ignore the S portion of this, though we will get to the S portion of a URL, a secure HTTP connection, in a later module. But you've probably done something like this and gone to it in your web browser before. And the one thing that's missing from this right now, and I'll send it just to show that this is going to fail. It says failed to connect. The reason it fails to connect is normally HTTP is on port 80. So we've seen port 1234, we've used it. Right now we're using port 8000. Normally HTTP is on port 80. So by default, that is the assumed port of connection. It doesn't have to be port 80, but that's the default. So if we want to specify that, hey, no, this is actually on port 8000, we put a colon right here and type 8000, hit enter, and we got our very interesting message. Now you see there's no new line character here, and so my terminal continues here. It's kind of annoying. We'll just solve that by adding a new line in the message and run it again. And we get our very interesting message. So now the length of this is 36 because we got a bonus little new line character on here at the end. Okay, so this is curl. Curl just gives us the body. If we want to see everything happen like we did with netcat, we can do -v, and it's going to show us everything that it just did. So it sends get/message.txt HTTP 1.1. It sent this host header, not required, but you certainly can. It sends this user agent thing, and this user agent thing says, hey, I'm curl. In case there's special behavior for user agents, these days it's not super common. There are still some reasons to pay attention to the user agent. So for example, if a user agent is saying, hey, I'm a mobile web browser, it might serve you content that's different. So for example, on your iPhone versus let's say your laptop, it might say, hey, this is a mobile user agent, and I want to send slightly different stuff to you because you're on mobile, and so this is what I'm going to send you instead. Now, normally we're not going to really get into this. Normally that's kind of more commonly done through CSS, but you could imagine doing that through the user agent. And then the server responds 200 OK, server date. Now we can see content length, no longer 35, it's 36. And this is a very interesting message. Okay, and then one final little, I guess, example of this that we'll do real quick is let's talk to a real web server. Real, I mean, this is real, but let's talk to something over the internet. And what we'll do is we'll curl example.com. And we'll put HTTP, put a nice slash at the end. I think this is probably optional here. And we will curl that. And now we're talking to a server out there on the internet. This is the example.com website, and it would just return some HTML. So normally you wouldn't really care too much to curl this, right? Because you're just getting HTML. I mean, you'll probably get some feeling, right? This is the title. We got some CSS I was talking about. Got something saying example domain. This is an example domain for illustrative purposes, blah, 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 blah. And how did that work? Well, curl-v. If we look at this, we're going to see we sent get/http 1.1 example.com user agent accept this. It says okay, gives us a whole bunch of headers that we don't really care about right now. We will see somewhere in here content length 1256. So this means all this HTML is 100 or 1,256 bytes. and it sends us the content. And this content could truly be anything. We're specifically sending HTML here, but it doesn't have to be. Okay. Now, if we wanted to, for example, this right here is a link. This ahref thing, it's saying, hey, you can come over here for more information. But guess what? We can curl this as well. And this does have an S. Now, curl handles HTTPS just fine. We'll ignore the fact that it's HTTPS because it's not super interesting to us right now. But we could curl this thing as well. And something else happens, actually. It's kind of cool that this came up. It says 301 moved permanently. This document has moved here. So let's go ahead and add -v. And I'm going to, do we need this? Probably don't need this. Does this show up just fine? Okay, I'm also seeing some questions. So make sure we address those. Yeah, this shows up fine enough. Okay. I'm also seeing questions in the chat. What is the difference between 127.0.0.1 and 0.0.0? The difference is, in one case, 0.0.0.0 is kind of like this weird IP address. It's not really an IP address. What it means is I'm listening on all of my network interfaces. So you could potentially have multiple network interfaces on your computer. You could have multiple IP addresses on your same computer, all speaking over different interfaces. Like you can imagine physical Ethernet cables being plugged into your computer. You can have multiple of those things plugged in, each on a different IP address. And so when you say 0.0.0.0, what you're saying is I'm willing to receive connections from any of these. Whereas 127.0.0.1 is the localhost IP address. And you're saying I only want my localhost connections. So I see something saying some users claim that when trying to send a HTTP post request over netcat, so we'll get to post requests here in a second, over netcat, it doesn't let them leave an empty line after the headers and before the data and just immediately exits. What could be the cause of that? Doesn't let them leave an empty line after the headers and before the data and just immediately exits. Well, we'll get to that in a second. We'll do an HTTP post request here in a moment. But first, let's show off this 301 moved permanently thing. So if we do curl -v, we will see, and you'll see that this TLS stuff, this is the HTTPS, the S portion of it. We don't really care about that right now. What we're going to do is we're going to see get/domain/example on host www.iana.org, user agent curl. And so we previously saw a 200 OK. We saw a 404 not found. This is another code that can be used. This is the 301 moved permanently code. And what that means is, hey, I am not here anymore at this location. Like we're not at this /domain/example location anymore. I have moved somewhere else. So if you want this, you're going to have to go talk to that person, to that resource. And the way that it specifies where that other resource is with location. And we can see right here, the location is here. So we were talking to www.iana.org/domains/example, and it's telling us, no, don't go there. Go to help/example domains. So it's no longer at domains example, it's now at help example domains. And so if we follow that redirect manually, we'll do a curl of that. We will see, now we get a whole bunch of HTML related to whatever this is. And if we look at status code, we will see we got a 200 OK. So it says, yep, I found that resource. Here you go. Here it is. So it's really, at the broadest sense, HTTP is for communicating with resources. It's right now we've seen getting resources, so it's just fetching some resource, getting the contents of it and displaying it to you. Of course, you might use a web browser to render this. You've all used a web browser before. When you see this visual representation of a website, that's the HTML being rendered. But this is the underlying data. Okay, so this is the get method that we've seen. And actually, just real quick, one more thing, just to show that I can do this with netcat one more time. We can get this thing. So this right here, if we take this message, so we'll actually take this. We don't need this. Netcat is adding that. This thing right here, and we save this as request. So this is some request. And we can cat this request. So this is some data. And what we can do is we can just ship this off to this. Instead of 127.0.0.1, we're going to connect to this host. We don't put this all in here because this is the resource. This is an HTTP concept here, whereas this is a networking domain right here. So www.iana.org. And we are going to connect over port 80 because we just know it's port 80 because HTTP by default port 80. And if we do this, well, we get a bad request. Let's see if we can fix that up. We need that. Let's see. Yes, it looks like it. No, it does not look like it. Interesting. So the reason it's hanging right now is it does want that second new line. So the structure of this is such that we need 2 new lines here at the end of our HTTP request, as we talk about in the lecture videos. So right now we're getting a bad request. Now I have a feeling I know what's going on here. And my feeling, some web servers are very particular. Let's try doing this by hand just to double check that it's not something with this cat thing. I don't think it is. That wouldn't really make any sense. But you know what? I'm going to check anyways what's going on here. We'll do that. We will do that. And we'll do that. Yeah, it's not liking that. So my feeling of why it's not liking that is that it wants not just new line characters at the end, so \n, it wants \r\n, which is the technically correct line ending for HTTP. So if we look at request, it's got these new line characters, and it's going to look the same even after. But if we run this through something like, let's actually just quickly jump into Python. And we open this file, and we read it. We're going to see that it has new line character, new line character, new line character in here. My feeling is that it's going to end up wanting a \r\n. Let's see if that is the case. So I'm replacing all these new line characters with \r\n. Again, watch the lecture videos to see that that is in fact the correct format. And we will open request again and write that. No, we won't. And we write that. Okay. Oh, no, we lost it. We will write, we'll just copy it. This right here. Okay. And now if we cat request, yeah, see now we get it. We get the contents. So the reason for that, again, this is kind of unfortunate that our first example, one of our early examples fell into this, but technically it's not \n at the end. It's \r\n. And if we cat this, as you're going to see, it looks the same. Right? It looks exactly the same. But technically now these line endings have one extra little character at the end. I think it's possible, now that I'm thinking about it, that if I netcat here and say that I'm speaking HTTP 1.0, I almost think it's not going to have that issue. Let's see. We'll add host. No, not true. It also wants \r\n. So that's what's going on here. Fortunately for you in these challenges, you're not going to run into this \r\n nonsense. A lot of web servers are totally cool with just \n at the end of lines, but technically it's supposed to be \r\n. It's just a bunch of servers choose to make that optional. How does it know which location we are trying to go to? It knows where we're trying to go to when we do this because our message, or not our message, our request says that's what we're trying to go to. It says, give me /help/example domains. I want this resource. Give me this resource. And when I do this, I'm saying I want to connect to this thing out on the open internet. So this thing out on the open internet, some server out there, and we want to talk to port 80 on that server. And I just, in the same way that at the very beginning of all this, I showed you an English request for a document, this is an HTTP request for a document. Now, even this is all optional. Certainly the user agent and the accept are optional. Let's go ahead and show that. The host, I think in 1.0 is optional. 1.1, not so sure about that. Let's do rn. So if we do this, yeah, you'll see, oh, not true. Well, I mean, it is true. I mean, we're speaking HTTP, but it's not thrilled with us. You'll see this is a website that does in fact use the user agent. This is a little bit silly because as we can see, I can put whatever user agent I want, but it's saying, hey, user agent required. You need to send me your user agent. This is another HTTP code. We're getting 403 forbidden. So we've seen 404 not found. This is 403 forbidden. It's saying, hey, I'm not letting you do that. So let's go ahead and make it happy. We'll add rn, and we'll say, what will we say? We'll say user agent test, right? We won't even say that we're curl. We'll just say we're test. Let's see what happens. And it's totally fine with that, right? This is why it's a little bit silly to require something like a user agent. It doesn't really, like, why? Like, it's the client can send whatever they want to send as their user agent. So what are you really gaining there? But, it's up to the person implementing that web server they can do whatever they want. They can say it's required and give you a 403 otherwise if they so choose to do so. Okay, and right, as a reminder, this is now what we're sending. So this has been an example of us fetching resources. So fetching resources is super cool. Now we can get all these documents across the internet, which is obviously useful. But what if we want to start manipulating resources on the internet? So for example, and I'm trying to think about how to show this. I might switch. How do I do this? Let me go ahead. I'm gonna have to mess with OBS real quick. Yeah, we'll mess with OBS. Basically what I'm gonna need is I'm gonna need to go into desktop mode. I realize now that a terminal isn't quite enough. We want to be able to add desktop. So what we're gonna do, we're going to duplicate my current scene, that, Probably you're going to see this change. That's fine. This, we're going to delete that. So we're about to lose the terminal from being visible. Okay. We're going to add, where is it? Screen capture. New screen capture. Now you can see OBS. We want window capture. We want, I think we want this guy. Cool. We will take that. Make this as big as we can. We'll make this bigger. Cool. Gonna have to make my face reappear. Cool. There. We'll center it. Oh, no, we're moving everything. Not what we want. Oh, we're still moving everything. Still not what we want. Oh, I see what's happening. Oh boy. So we got that. Oh, there's a disaster. What's happening? I'm so confused. We got this, we got this, we got this. What the heck's happening? Oh, I think I see what's happening. Oh, this is a disaster. We want this right here. There we go. Okay. I have to fix this. Nice. OBS. Really, this is a user operator issue here. Okay. Fix it after the stream to make it just right. Okay. Now we got a desktop view. So we got terminal view, got desktop view. Very cool. All right, fancy. Let's go ahead now and interact with an even more real web server. We're not going to just interact with example.com. Let's go ahead and interact with the pwn.college website. And the way we're going to do that is we're going to open Firefox and we're going to point it at pwn.college. The only reason we're using the terminal is I'm realizing I don't have, actually, can I access it without the terminal? Oh, we can. Web browser, is that going to launch Firefox? Oh, it does. Cool. All right, no terminal required. We're not that fancy. Okay. And we're accessing pwn.college, and you're going to see, so for example, I'm going to do inspect. I'm going to do network. I'm going to refresh the page. And what we're going to see here is a whole bunch of HTTP things. Or actually, before we do that, let's sign out. We'll get to being signed in here in a second. So we go here, we can see a whole bunch of web requests are being made. And what are these web requests? This is HTTP. So the way that Firefox is showing this to us, it's kind of parsing it out a little bit. We're going to see that, for example, my request headers, we send this accept, we're sending this cookie stuff, we're sending this host stuff, we're sending a whole bunch of headers. So web browser is a little more complicated than curl in terms of what they're doing, but the same structure looks the same. And we're seeing that we're getting a response. The content length is 11,000 bytes. So we got 11,000 bytes back from the web server. When we loaded up this page, we got a date, we got a server. It doesn't really matter, but these are things we got. Importantly, we got a 200 message. So that's pretty cool. We got a 200 OK. Again, we're not able to see, well, if I do, yeah, so it's parsing it out for us. We don't get to see just like, oh, wait, there is a raw. Let's see here. Raw. Yeah, look at this, right? So this is, it's not speaking HTTP 1.1. It's actually speaking HTTP 2. But the same idea is there. And if we look at this, we can see it, right? It looks basically the same. The same idea, again, it's there. We're not speaking 1.1, we're not speaking 1, we're speaking 2, but it's the same idea. We got this host thing, we got this user agent thing, all this stuff. And what comes back is, I mean, this is it rendering it, but a whole bunch of HTML comes back. In fact, we can switch over to inspector, see all this HTML, this came back. And in fact, if I switch over back to my terminal, let's do terminal again. If I do curl HTTPS, again, we'll ignore the fact that it's in S for a second here, or until we get to the cryptography module. And I believe we're going to dojos. Yes, we're going to dojos. And we curl that. Right, we're getting all of this HTML, and it's the same exact HTML that we're getting in Firefox, and it's being displayed to us. It's just here, this is the raw data, and before was a rendering of it. So if we go to the curl-v this, again, we can see curl knows also how to speak HTTP2, so we're speaking HTTP2, but the same idea is there. We get /dojos HTTP2, and we get a 200 OK. Technically, you don't have to say OK here in this case, but it's the same idea. It's 200. We got the resource. OK, hopefully that makes sense to everyone, that we can see that it's the same idea. One's visual, right? It's the web browser deciding to render that HTML, and we don't really care about rendering HTML in this class. It's not super interesting for us. But we're able to send some content, some piece of text, which is then further a part of what's going on. We're focusing on the HTTP side of things. We don't really care about HTML right now. Okay. So that works. So we're able to fetch things, right? We're able to fetch all of our dojos, right? And actually, just to really show this, let's curl. Hold on, we got to switch here. Let's curl and grep for CSE365, right? If we do space, we'll see CSE365, fall 2023, fall or spring 2024. These are all in here. Alternatively, if we go and let's switch here. If we want to look at the syllabus, that's not how we look at the syllabus. Oh, that's right. We don't show the course unless you're logged in. Let's see if I can remember it from memory, the URL. Let's see here. Let's do /dojo/CSE365 spring 2024 course syllabus. I think this is the URL for being able to see the syllabus. And if we look at this, we're going to see our syllabus. Syllabus update, blah, 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 blah. Late submission policy. We can see this is all the HTML for rendering the syllabus. Right? If I grep for myself, grep Connor. We can see instructor, Connor Nelson. In here is a link to my website. Got a mail to in here. This is all just HTML. This is how it works. Your browser isn't that fancy. I mean, technically your browser is pretty fancy, but it's really not that complicated to get to the core technology of what's going on here. We're just speaking HTTP, and the underlying data that's being sent to the HTML, but it really doesn't matter. You could send plain text over HTTP and just read it like a text document. It just so happens that we want fancy things with cool renderings so that we can get something that looks like this, with all this cool green and like scoreboard with images and layout and, make it look kind of cool. But you could send text. There's no reason you couldn't send text, and text would work just fine. Okay, so this is still just fetching resources, though. There's kind of like a whole 90% of the web that you're probably really thinking about, the modern web at least, is not just fetching resources. You're interacting with resources. So for example, we've got this thing right here. Let me get rid of that. Let's just go to login. Let's not mess around. We've got this login resource. And once again, hopefully this is not going to come as a surprise, but we could curl the login resource. And what we're going to see, like grep for username or something, what does it say? I guess it's user space name. User space name. Where the heck is it? Well, here it is. Username or email, password. And then somewhere in here, there's a submit button. We got a forgot your password thing. We got a submit button. Okay. So, and I see in the chat someone's very excited about this. Yes, it is very cool stuff. It's cool how like simple the underlying thing is. How does this work from the browser perspective of us logging in? So I'm not going to log into my real account. Fortunately, I got a demo account. The password for the demo account is not complicated, so don't mess with the demo account. But yeah, I can always fix the password if I have to, but don't mess with my demo account. We are going to log in and watch how that works. So here's how it works. We're going to pull up our network tab so that we can watch the request go through. What we're going to do is we're going to type in our username, demo. I'm not going to tell you the password, but unfortunately for us, we're going to see the password. And we're going to hit submit. And this logs us in. So let's go to this here. So everything we've seen before has this method of get. You've seen get in all capital. Here, we're kind of manipulating a resource. We're interacting with the resource. We're not just fetching a resource and like getting its contents. We're like interacting with it. And very commonly, what it looks like to interact with something is rather than get in all capital letters, it's post in all capital letters. We're going to see the structure of that here in a second. Though, again, watch lecture videos. Lecture videos have already talked about the structure of this. This is just us showing that this is not a lie, right? This protocol, it works exactly how we're saying it works. So let's look at it in terms of a raw request. So instead of get/login, we post/login. And we have our host, got some user agents, and where is it? Oh, I guess it splits out the headers because these aren't headers. We'll see how this works. So in the same way that when we fetch some resource, it gives us content. When you post, you can send some content. So not just the headers, but actually some data after the headers. And where I guess in Firefox it displays that is we have this form data. Let's show it as raw instead. What we send to the server is name equals demo. And I'm realizing this example is going to be slightly more complicated than I would have wished for, but we'll push through anyways. We get name equals demo, password equals, well, it turns out you found out the demo password. Keeps going over there. It's sending this also, and the reason it's sending all this, the browser sends this, is the HTML just instructs what's in this form thing, and when you hit submit, it's just posting it. So the browser is translating this HTML element thing into a new request when clicked on. So it happens to send this also. It doesn't really matter. This nonce does actually matter. Conceptually, it does not matter, but the server does deal with this nonce, and we'll actually deal with understanding the nonce a little bit more at the very end of this course when we get, or not the very end, but near the end of this course when we really get into web security. We're starting with the fundamentals here. This nonce thing is just a random value. And it turns out that attaching this random value has a purpose. We're not going to get super into that purpose right now, but this random value does actually have to be included for the purposes of this web application. In the broader general sense of posting HTTP, you don't necessarily need some sort of nonce thing. It's just for the purposes of the the logic of this web application, it does. So let's go ahead and type this by hand then. Actually, one more thing that you might have noticed is it does this post. We get a 302. So we saw a 301 before. This is a 302. This is like a temporary redirect. So it says, okay, here's what I'm going to tell you. I'm going to say, you've logged in. Now go fetch this resource. And it says to go fetch, let's see here. It says to go fetch /challenges. And then we fetch /challenges. And it turns out /challenges actually also redirects us. And it says, go check out /dojos. So we do a redirect to a redirect. And suddenly now we are at /dojos. Now, how does it know we're logged in? So if you pay attention in the lecture videos, we talk about how HTTP is a stateless protocol. But for example, when I go to this settings page, right, and I've got my username in here, when we look at this request, how does it know that my username is demo? All we did was get /settings, right? If I go and switch over to my terminal, let's switch to the terminal, this right here. If I switch to the terminal, we're going to see that if I curl https://college settings, well, we can see immediately I'm not getting anything that could possibly contain my username in here. It's because I'm not logged in. It's actually saying you should be redirected to log in. So we see here that we get a 302. The 302 says to go over here. Now, the reason that it all just works out, even though it's a stateless protocol, the magic secret sauce here in all of this is this thing called a cookie. So you've probably heard of a cookie before. Probably heard that cookies are evil. Cookies are not evil. There's nothing evil about cookies. Cookies are how we manage state. You can use them for bad things or whatever, for tracking and I don't know, however your perspective is on that. But cookies are a fundamental, important technology of the web. This cookie thing, this says my session. This session thing is how the web server knows that I'm logged in. This right here basically says, in a very secure way, depending on your threat model here, it says that I am logged in as the demo user, if that's what this session cookie says. And so now whenever I fetch things, all I'm doing is I'm sending this cookie along. And the reason I know to send this cookie along, oh boy, we lost it. Hold on, let's log out. We will log in. We will send demo unknown password. And what we're going to see here is we post to login, and one of the headers that it sends to us in this protocol is this set-cookie thing. This set-cookie thing, this is how we know to send this. Set cookie means now whenever you talk to me, include this cookie. So this is really simple. I mean, we're seeing a whole bunch of headers, and maybe that's like muddying the waters a little bit. But let's go ahead and just include this cookie. How am I going to copy this? We're going to do this, copy that. Let's use this cookie and hit settings again from my terminal. And we're going to see that it no longer redirects me. It knows I'm logged in. This cookie thing is the only thing encoding for that. So let's switch over to the terminal. Let's go ahead and let's actually just do it right here. So we'll do, well, no, we'll just do it right here. Netcat, .college. Do we want a netcat? Oh, the issue with netcat, got one issue. issue with netcat is that S is going to get in our way. Here's what we'll do. We'll use curl, and it'll tell us how to send a cookie. Cookie, blah, blah, blah. Cookie, data, file name. Yeah. Okay. So we're going to curl the settings. Again, it says, hey, go log in. That's basically what it's telling us to do. It's doing a redirect. But if we include this -b and paste this thing, session equals that, it no longer says to log in. It now knows that we're logged in. And if we look up here, we'll see my username is demo. I'm now logged in. And how did this work? All curl did here, and the reason I'm using curl instead of netcat, unfortunately, here is because of that S. That S is going to get in our way. We can't actually just speak HTTP to this server. We have to go through this thing called TLS, and it has encryption and stuff. But if it wasn't speaking HTTPS and was just speaking HTTP, it would work just fine. We will see that this cookie is right here, right? All it's doing is get settings, pass along the cookie. And it says, okay, and here's your settings page. So that's how we're maintaining state. And specifically the way that we're logging in, so I guess to really hit home here, we're just doing get/settings cookie this thing. This request, and technically we do also, in the case of this, need this host header for pwn.college. Depending on your context, you don't need that, but here we do need that. This would work, and it would just say, hey, I'm at, go get me the settings page, use this cookie, and now it knows that we're logged in. Okay. Let's also manually do that login process. So if I curl HTTPS pwn.college, actually, real quick, let's make sure. I think it's not willing to speak HTTP, but we'll confirm that that's true. Netcat, or we'll do cat request netcat pwn.college port 80. Yeah, see what it's doing is it says moved permanently. And when we do this, it's redirecting us and saying, hey, you need to go to HTTPS. So it's redirecting us from HTTP to HTTPS. So that's why this does not work. If our server was actually speaking HTTP instead of HTTPS, it would work. But unfortunately, we're not that lucky. But we saw how you could do it with curl. And we saw what the structure is. It would look like this. If it was speaking HTTP, this is what we would be sending. That's it. It's really that simple, just this cookie header. And the reason we know that is because of the set cookie header. So let's use curl to log in now. So if we do curl HTTPS pwn.college settings, so we go here, it says redirect, and it's redirecting us to login. Specifically, it's redirecting us to login with this like next equals settings thing. That's how it knows when you log in to go back to settings. That's just like an extra little feature of this web application. Not an HTTP concept, just like how the logic of this web application works. What we can do is we can do, let's follow that redirect actually by just manually now typing in /login. And maybe we'll even do login ? What was the full redirect? Just to show how this works. Login next equals /settings, I think. Cool. So it's asking for a username, a password, and specifically from an HTML perspective, it's going off of this name thing. So that's how it knows that its name equals whatever we type in and password equals whatever we type in. That's also where this _submit thing came from. That probably doesn't really matter. And that's also where this nonce thing came in. You'll see in here we have this field of input nonce. So let's actually copy the nonce because we do need to include this value. Even though it's hidden from us, it's in the request. So we'll say, how do we, now the question is, how do we specify this? Well, what we were going to want to do is we're going to want to post to /login question mark. Well, let's just go to login. And what we're going to do is we're going to say name equals demo and password equals something very hidden, and nonce equals this thing. So the way that we can specify that in curl, so man curl, this is going to say, if I look for form, yeah, I think it's this -d flag. Yeah, so --data, or just -d. So what we're going to do is we're going to curl this thing. We're going to say, we're going to copy this. This is what we're sending. Whoa, that work? Immediately sent it. So curl -d, name equals demo, password equals very hidden, nonce equals this thing. And when we're seeing a forbidden, it says you don't have access to the requested resource. It's not really thrilled with us. If we clear curl -b, what got sent, let's make sure that curl is doing what we think it should be doing. Post login, I think it sent it. It's not showing it to us for some reason. But it's saying content length of 94. Oops. 94. So that sounds promising. Real quick, let's curl the settings page. Well, let's curl the login page. Let's get that nonce again. I'm not totally sure how frequently this needs to be updated. Let's do curl -v. Oh, I didn't actually do, did it do a post before? Automatically? Let's see. If I include data, it should be doing a post, I believe. Yeah, it did a post. So let's do curl -v to get information. We want to send this blob of data. We want to do this at pwn.college login. Says again, don't have permission. Why do we not have permission? Something's going wrong. This is why you always have the computer just do it for you so you don't do it by hand. But you gotta understand how it works. So we're gonna figure out how it works. How the heck does this thing work? $94. Why the heck? Okay, well, actually, one thing I saw while we were looking at curl was encode data URL encode. I guess we can try to use this URL encode thing. As we talked about in the lecture videos, this thing does need to be URL encoded. But nothing in here looks like it needs to be URL encoded. Actually, idea. Hold on. No. I'm seeing the login question mark next equals stuff. Yeah, but I got rid of that just to make it simpler, make sure that we're not typing that in wrong. You don't have permission to access the resource. Maybe that thing that I said you don't need, you do need. Let's actually go ahead and let's go ahead and include that as well. Let's curl login. I don't think this submit thing is actually being checked on the web server. Well, maybe it is. Did I type nonce correctly? Nonce, yes. Take this new nonce just in case the nonce needs to be updated again. And submit equals underscore submit. And nonce equals that. All right, let's see here. Curl v that HTTPS college login. Don't have permission. Why do I not have permission? See, the answer is like, we're speaking HTTP correctly. We're just not sending it correctly. We're not making the web server very happy. Maybe I need to include a cookie, like prematurely, because it technically is doing a set cookie every time. So maybe we should try to respect that. We'll include this cookie as well. No. Hold on, now let's use this nonce. See, this stuff is not easy to do by hand. That's why we're making you do it by hand. I don't have permission. So we're not getting a new set cookie. We are doing post to login. We're setting our cookie. The length of this thing is 109. 116. Wait, did I not include though? Oh, we do have our submit. Okay, hold on. What's going on here? Something's happening. How long is this thing? Well, that is 116. I guess it cut off part of it before. Well, we'll include the new nonce. Yeah, I see in the chat that someone's saying that we need to go to /login question mark next equals /login. That is technically what it's instructing us to do, but that next thing is just saying where it's going to redirect us to after we log in. Let's try this dash data URL encode. Just be careful. Well, no, let's look at this. This will cause passenger using xwww form URL encoded compared to -f. What is -f? Dash form. Name equals content. I'm actually wondering. Let's try it. I'm almost wondering if I need to do this. Like specify a whole bunch of -d options. Let's try it. Don't have permission. Why do we not have permission? Do not have permission. Curl. Let's include our cookie. And go to login. This says to include this nonce. So we'll say nonce equals this. This is what happens when you target a real web application. Submit equals submit equals, I think it was underscore submit that. Was it name? I think it's name. Wait a second, it worked. What happened? What did I even change? Okay, so this is doing our login. So we have successfully logged in because we're getting a redirect. Hold on. Now I want to see if this matters. Password equals this. I don't even think this matters. Let's see. Let's confirm now. It's getting a redirect. All right, I have no idea what we changed. I don't know if my nonce was incorrect before, but we are now getting a redirect. So we've successfully logged in. And you'll see we're getting a cookie that we're posting along. We don't even need a set cookie again because, well, I guess it is telling us to set cookie again. So we could take this cookie and we could do curl-b this HTTPS pwn.college settings. And we will now see our username is in here. Yeah, demo@example.com, etc. All right, so we logged in with curl. Cool. Took a while, but we got it. One final thing I want to show before we wrap this up is Python. So far I've showed netcat, I've shown curl, we've logged into real web applications. Let's use Python now to do this. So if we start up Python, or actually I prefer IPython, the same idea. It's just like, instead of this, we got this. It's just slightly nicer features in here, but it's the same idea. It's the same language, still Python. If I want to do this with Python instead of netcat or instead of curl, what I can do is I can do import requests. And what I'm going to do is split editor down, new terminal. Let's go ahead and netcat listen 127001 port 80. We can clear that out. And then what let's do is let's make a web request in Python. So the way we do this is we just import requests and then we do request.get HTTP 12700180. So it's just, not /80. Well, technically you can do /80, but we can see what we get here for this is get /80. So that is what's coming in. We can see the user agent is Python requests. Again, this is totally optional. And now we have sent a request. of course, really what we meant to do was that. And we can fetch any resource. So let's start up. Actually, let's just connect now. We don't even need to do this. We showed that the request is coming in. What we can do now is let's interact with pwn.college. So pwn.college/settings, for example. And we will see that we get this response object back. If we want to view the contents of that object, we will just say response equals this. So now we have this response thing in Python, response.text. This is all of that HTML. And that's what we're seeing. So if we wanted to do the same thing that we were doing before in curl to log in, instead of .get, instead of request.get, what we want to do probably is, well, let's first start by going to the login page. Let's look at the .text of that thing. Somewhere in here we have a nonce. We're going to go ahead and copy that. So this is our nonce thing. Just quickly looking for a big hexadecimal string. That's how I'm finding it so quick. And then instead of getting the request, right, like we did here, what we want to do is post to HTTPS pwn.college login. And what we would do is we would say data equals, and we'll say name is this is this, and nonce is this. And we will post that, and we're going to see that we get a 403 like we did before. Someone's not happy. We're getting the same error we were getting before. Thinking what we're missing here is are we missing our cookie here? Let's see. 49. This is definitely, I mean, the nonce is changing every time. So let's do this. I think the nonces last for a while though. This is totally web application specific. Nonce, this. Text, we'll say response equals this. Response.text. So we're still failing to log in. What we can do though is we can grab response.cookies. Oops, response cookies. Let's go ahead and take our session value thing. And now what we'll do is we'll include the cookie. So actually, here's what we're going to do. We're going to do it as the web browser would do it. We're going to get HTTP s pwn.college login. Right, so we're getting, oops, oh yeah, requests. Response.cookies. So response.cookies has a session cookie. So this is just a Pythonic wrapping around HTTP. So we take all the cookies, we specifically grab the session one. This is what it looks like to use Python. If you've never used Python before, don't worry about it. You'll catch on very quickly. It's really not that complicated. So we're grabbing the cookies. We're specifically grabbing the session one. This thing's called like a dictionary. We're grabbing the session out of the cookies dictionary. And that has this value. So every time we do it, we're seeing the cookies changing because every time we're doing it, we're making a new web request. So we're going to take the session cookie, and then what we're going to do, and then also actually we have response.text. Somehow we're going to need to get this hexadecimal thing here. So somewhere in here, we've got something that looks like this. If we split on this, so this is just going to be a simple parsing thing. We're using Python to very simply parse this. Or you know what? Let's use regex. It will be slightly fancier. we're going to do import RE. We're going to do refind research. We're going to search for this thing. So we're going to search for a pattern inside of a string. Re.search for a pattern inside of, and then a string. So the pattern is going to be this with 0 to 9, A to Z, a whole bunch of them. This thing. Oh, and then we got to pass it response.text. Okay. And then groups 0. Or group 0? Yes. Well, no, we want group 1. Yes. See? So now every time we do it, basically what we're doing is we're looking through all the HTML. We're looking for something that looks like this. Specifically, the interesting regex part is that we're matching for this. I know this because this is the format of it. It's always 0 through 9, A through Z. You'll pick up, as you do this sort of thing more often, you'll pick up what a hexadecimal string looks like. This is a very hexadecimal looking string because all the characters are 0 through 9, A through Z. So 0 through 9, A through Z. Actually, I said A through Z. That would be ASCII or alphanumeric. Really, it's A through F, but that works also. And then, so this right here is our nonce. And then what we're going to do is request.post. And we're also going to say cookies equals session cookie. And the response is this. Response. And we got a 200 OK. And we can see that we're getting a redirect. Actually, we're not getting a redirect. The reason we're not getting a redirect is by default, requests follows redirects for you automatically. So follow redirects equals false. Python don't follow redirects. There is a thing, I'm quickly Googling it. Allow redirects. Now we will see we're getting a 302 headers location. We can see that it's redirecting us to challenges. Of course, if we turn this off, it just takes and shows us all the dojos. So for example, somewhere in here, 365 is in there, true. CSE365 is in there, etc. Okay, hopefully, I know this is a quick run through of using Python, but we can use Python also to talk HTTP. And this all looks exactly the same as this. This is what it looks like. It's just doing post/login. So in here, we're doing, I guess we'll specifically show, we're starting with get/login. HTTP 1.1, and we're saying host.college. And so we do that. And what we're getting back is a bunch of HTML that includes this nonce thing. And then we're also getting back a cookie that says session equals this. So we're just taking those two things, and then we're doing post login, HTTP 1.1, cookie equals cookie I was told to set. And then I guess we'll also say host on college. And then we're putting in nonce I was told, right? So we're getting a cookie, we're getting this nonce thing. The nonce thing, not super interesting right now, but technically it's relevant. And then this cookie thing. And all our Python is doing is matching that all up, right? We're doing the get, grabbing the cookie, grabbing the nonce, making a post request, using that data. So this is a more complicated example. We actually just jumped straight into a more complicated example in Python, but this is why you would use Python, is to programmatically start doing things. So you can use stuff like regex automatically rather than how we were doing it before, where we were just curling this thing, curl dash b this, no, login. Where we're just like curling clear curl https pwn.college login, not dash b, and we were seeing that there's this nonce thing that we needed to include. The browser's doing it automatically for us as well because it's this hidden input field in our form. And rather than like manually go and grab this thing, right, we write code because the code can do it. And that's why Python is cool. Is that Python, well, I guess we scrolled away from our Python. Let's see here, Python. That's why we use Python import requests, import re, because now we can just start gluing in code with our HTTP talking thing. Okay, so I'm seeing some questions in here. If you make sets of sets to correlate to your specific set, you can replace most of the letters for numbers knowing you only know the sets. Whoa, hold on, what does that mean? You make sets of sets to correlate to your specific set. I don't know what that means. Okay, and there's also a question of what is a nonce. Truly, a nonce is just a random value. And the reason it exists is truly, there's a security element of it. We'll kind of get to the security element in the later half of the course. But from a non-security perspective, in some sense, it's to make it so that you have to do this get first. It's making it so you have to do this get and also extract it and then send it along. But in terms of what its value really is, the server is just generating a random nonce and sending it in with the HTTP, in the HTML specifically, and expecting that you send that as well. So it's expecting that this nonce comes back. So it's making sure that you hit the login page, we're able to extract some data from the login page and then post it along as well. And there's a security reason for it, which again, we'll get into in the second half of this course, but that is all it is. It's actually a pretty simple thing. Yeah. So that is kind of a quick primer on HTTP using netcat, using curl, using Python. We covered a whole bunch of things. We covered 200 OKs. We covered 404 not founds. We saw some 301s, some 302s, some redirects. We saw 403 forbiddens. We showed that the location header is used in those redirects. We showed set cookie. We showed cookie. I mean, I'm kind of saying a lot of things right now, but this really that's everything I showed you right now. Is we're covering 90% of the protocol at this point, of the fundamental core part of the protocol. So you really this is HTTP. So even though maybe I said a lot of things, we only took an hour to say those things. And that is that. So basically we get to see passwords and his information for each level. Technically, you saw the demo password, but don't abuse that. There's nothing interesting about the demo account. It's not going to get you anything. I created it specifically for this demo. In terms of the challenges themselves, I guess I'll say, if we look at, let me quickly start a challenge. So someone's talking about level 4, for example. Let's just very briefly look at level 4, and we'll see the structure of these challenges in doing so. So let me start up level 4. Oh, I am realizing that I am doing that incorrectly. Hold on. It's 2024 Talking Web. This is the issue of not showing my whole desktop. Now you don't see what I'm doing. But we're just starting up a challenge. I'm starting up level 4. And I think we're going to need to refresh. Almost there. Okay, we started up level 4. Challenge. Well, I guess we don't even need to show a challenge run. What we can do is curl HTTP 127.0.0.1. So the purpose of these challenges, there will always just be a running web server. And if we curl this thing, we're going to see incorrect host. Value 127.0.0.1 should be blah. Right, saying this is the wrong host. So the way that you solve this is, first thing I would do is search for host. Well, yeah, I guess there is a specific thing. And it's saying this is the option for setting a header. So in the lecture videos, we talk about the format of HTTP requests. One of these things, as we've seen here today, is the host header. And we can set the host header by doing -h host : blah. And that will send a host header. So for example, we send -h host blah blah boom, got the flag. So what we just did is we did get /HTTP 1.1, so eventually you can do the netcat level, and we did host : space this thing. And that's all we did. So you're going to learn in these challenges how to set various things. So for example, how to set the host, how to change the host. So by default, when we did this, we'll see that it was doing host 127.0.0.1. This is just because that's how curl implements it. It decides by default, this is what you put in as this argument, that we're going to parse out the host element of this URL, and we're just going to attach this header. Technically, you don't even need to send this header. But for the purpose of this challenges, you do, and you need to send a header that looks like this. And all these challenges throughout this entire module are just going to have you doing and manipulating different elements of an HTTP request. Sometimes you'll do post, you'll get into URL encoding, you'll get into sending JSON, because that's kind of something we skipped. And that is what you'll be doing in this. Is this Twitch session recorded? Yes, it is recorded. It'll be available on Twitch immediately as soon as I end the stream, which I'm about to do, and then also YouTube. Is there any good alternative to man? It's often being overwhelmingly dense. I've heard some people like, I think they're called like TLDR pages or something like that. Maybe you'll like that. You can look for some internet resources that talk about curl or talk about Python requests. There's docs for Python requests. Really whatever you like. In general, I would just do the man page and just search it. So when I do man curl, the way that I'm searching it is I'm hitting slash. So I hit slash, you'll see at the bottom, we've got this little slash thing that's there. And now I type in host and hit enter, and that's how it's just jumping somewhere. You can also like Google for man pages of these things, and just, this allows us to just quickly jump to a section, and I just read this whole thing. That's kind of what I'm doing here. Depending on what you're looking for, might be trickier, but really whatever online resources you want to use for getting yourselves familiar with these things. Also, you could ask on the Discord. Maybe people have found some good resources for explaining curl in another way or explaining Python requests another way. Would recommend that. All right, thank you everyone for attending my first office hours of the semester. Good luck on the assignment, and I will see you in my next office hours. Goodbye.